Okay, so we were looking at parse. Oh, did I start recording? Yeah, we were looking at parse road for our homework. Let's go take a peek. So last time we finished writing our thing for our cities. Have I taken this out? Oh, this still is the old. I am saving it every time, or am I not? Oh, let me just copy that. Put it here. Save. Okay. And we looked at the difference between a class and a struct last time. And then we looked at how can you build we built a road parts object. This guy needs to take in a town 1 name, a town 2 name, and then the distance between them as a number. And the homework was to kind of prove that, well, read in something from our file that looks like that. Well, although I think for the assignment, you're not actually reading it from the file. You're just proving that if you had a string that looks like this and you passed it to this parse road thing, it would give you the thing that you need, where parse road takes in a string in that format and boils down to this guy. All right, so we're doing some string manipulation stuff. So we're going to have town 1, comma, town 2, comma, the number. All right, so we want to start working with this. All right, so a couple different things you can do. Now, you probably could have gone and looked up, and I'm sure there's some sort of thing built into C++ for reading in from the string. In fact, you could probably do scanf. Scanf will take in a string I'm not going to do it this way. I just wanted to show it to you. Okay, I think this will do it. Assuming this works with new style strings. This actually, we don't even need it to work with new style strings. This will probably tick you off. How this guy ends up working. So we'll say string town 1, string town 2, int distance s scan f. This is in what, standard IO, I believe. So that's standard input output, old from the C programming years. So we're going to read in from road string, and it's probably going to make me convert that to a traditional C string. And then I show it the format the string is currently in. So it's going to be string, comma, decimal. And then I tell it the strings to put those, or the variables to put those things into. Notice you're passing in pointers to all these things. So your string and your month are already pointers, but the day was an int. So you're giving it the address to it so that this kind of goes along with something we looked at a couple classes ago where some old style functions, they wouldn't actually return a value. You would actually just pass a pointer to it and it would update it with the information. I think we did it for file reading, right? But so this will be pretty similar to that. So I'll pass it town 1, town 2, and the address of distance. And then we'll go ahead and just do a C out. Town 1 space town 2 space distance. I expect this to break because scanf wants traditional char pointers, not strings. So it wants a char pointer to be passed to it, where I currently have a string. I think we have it called like 2C string or something like that. String to C string, C plus C underscore str. Got it right there. That's a function, right? Yep. I should be able to output those guys. Just for the moment. I'll comment out these so we can just focus on this thing. Oh, no return statement. I'll just return null for right now. Make sure road string is coming in. Oh, is it okay with? SCNF might be written in terms of these guys now. Yeah, wants it as a basic const char string. I originally had. Okay, yeah, so it's complaining that it wants these as a char pointer and it got a string, fine. That's where I had made those guys char pointers. Size of a char. Funny thing is, I was trying to show this to you as the easy way of doing it, but it's an interesting way of doing it. And then this is coming out as a char pointer. There's the original. Then we call this scanf, passing it my original string, telling it it's in the format of a string, followed by a comma, followed by a string, followed by a comma, followed by a number. I passed it the three things to fill up. And it did not actually split them. This is saying a space. Well, I guess without messing with it too much here, because we're going back and forth between old strings and new style strings. The way scanf works, scanf is how we used to read something in from the end user. This is equivalent to the modern day C++ cin function. Scanf read in from the user. Scanf, instead of it reading in from standard input, which is the keyboard, it reads in from a string. So what I was doing here is I was saying read in. So this is going to be at least pretty close. There's probably a weird syntax thing for the format of this guy. I'm saying here is your input string, the C string version of our road string. So this guy's a char pointer. And in fact, just real quick, since I'm hard coding it in there. Just see if it works on that. No longer takes in a char pointer up here too. Yeah, it read it on the same. So let me just undo both of those. So the idea is I would say, here is the string, that's the input. This is the format of that string. The format of the string is a string, followed by a comma, followed by a string, followed by a comma, followed by a number. So I'm describing what the format of that guy is. And then I'm passing it the variables that I wanted to fill up with those three pieces of information. And scanf will go through this string and peel off the parts of it, parse out the pieces of it to fill up those three variables. And I'm sure I can bang on this for a few minutes and get it to work. But right now what it's doing is it's reading into town one, the entire thing. So it just said, oh, here's your string, no problem. I'm just gonna read the whole thing into your 3 variables here, which obviously was not what I was looking for. But it's probably a difference between the different versions of this guy's on spaces. Let me just quickly switch it over to spaces. Yeah, it did it for that. I'll just show this real quick, even though it's not what we ultimately want. So came in like this. This was town one, this was town two, this was the distance. It did piece those guys out into individual variables. I'm not sure why it's not a fan of me saying, well, it's going to be that followed by a comma, then that guy followed by a comma, and then this. And then me just making sure that it could be that this is part of a string. So since that is part of a string, it's not well, so what a space. I don't know. So whatever, but that's how scanf roughly works, is it allows you to pass in a string and allows you to piece things out. Now, in our case, we're working with new style strings. We're probably going to write our own parser that's going to walk through and go and build up strings as we find commas and that kind of stuff. So we'll go ahead and take in our road string. Let's get rid of. So we know we're going to have a string town one. That guy will start off as the empty string. We're going to have a string town two. That'll start off as the empty string. We're going to have an int distance. All right. So the first thing we're going to do is we're going to start walking through road string until we hit the first comma. So we'll call this guy comma count is equal to 0. So we know we're going to walk through. So for int I is equal to 0. I is less than road string dot length. I plus plus. So we know that we will be looking at looking at every character in the string. So we're going to say if road string at the current bucket is equivalent to a comma, then we'll say comma count plus plus. Else, if comma count is equal to 0, town one is equal to town one concatenated with road string at bucket I. If it's equal to 1, town two is what we're building up. else. And I'm going to call this guy distance string. Distance string. Is what we're building up. So depending on how many commas we found so far, so the first time through, until we find our first comma, and we found 0 commas so far, we're building up town 1. Then as soon as we hit a comma, we increment comma count. And now as long as we have a comma count of 1, we're building up town 2. Next comma we hit, we increment comma count. As soon as, and then for the rest of the time, since we know there's exactly 3, we're building up our distance string. Okay. So we'll go ahead and do a C out, town 1. Put some dashes like this just to really show that we had. Sure this guy's still taking in a string, still taking in a string, still passing at a string. I need to make sure I return null since I'm not returning a value yet. I can concatenate there, can't I? Make sure my concatenation is the right stuff here. I got my Belgium, I got my Fredonia. I found the first 2. There was Belgium, there was Fredonia. Not like me building onto a string with concatenation like that. If it's a so need to be a string. You have to use the append function. It really doesn't answer though why we were getting all the crazy stuff here for the last one. Belgium, Fredonia. Oh, I think I remember. We had this issue. Otherwise, we have to typecast it as that kind of string. Oops, okay. So it's running off the end of the string. Does it not know the length of that string? That's what it thinks the length of that string is 18. Well, no, that looks right. That string probably has a length of 18. Should just be the contents of it. Why isn't that showing? It is supposed to be a less than. All right, so that's way better. But still doesn't explain why we got the weird outputs there at the end. Okay. Well, now the real question is why was that comma even, what was that doing? Okay, so that 6 is the last thing that printed out here, so we can dump that now. Sorry about that. Or I mean, was wondering how long it was going to take you to find that purpose bug. I put the bug I hid in there on purpose. All right, so those are our individual parts, town 1, town 2, distance string. But remember that this guy currently is a string. We need it as an int. So that is the A2I thing. So I can go ahead and say distance is equal to A2I of distance string dot C string. And then we'll just prove it's working by saying distance plus 20. So we're getting, it's a number now. All right, so once we have built up our distance string, converted to a standard style string, A to I converts a string, old school string, to an integer, store that in my int distance. So now I have 2 strings and an int. That happens to be the thing that I need to build my road parts. This guy, 2 strings and an int. So I'll go ahead and return a new road parts built with those 3 things. Town 1, town 2, distance. And did I teach road parts how to display itself? I did. So now up here, we should be able to say RP dot Display. That, and it's an arrow, not a dot. And there's the output of our road thingy. That was a nice direct path to getting that working. So in any case, that's one of our road parts, right? So a road part is taking in two strings and a distance, and it just goes ahead and sets these things up. Now, when we read in all of our road parts from our file, we're going to have them as a collection of road parts, similarly to what we had before, where we had a collection, well, we had a town collection, right? So now we have a collection of road parts. Let's look at this chat. Did somebody else find our comment earlier? Website.
I was asking about the website that you used earlier, but it's fine.
You got it? Oh, because I can give you the current code. But I'm not sure if that's going to update at the same time as I'm updating it, but I just put it in there.
Okay, thank you.
So in any case, if we were to fill out, create a new file here, did I do that last time, maybe called roads.txt. I'll just do it up here. So let's do our roads.txt like this. And we start filling our roads txt up with things in the format of what we just did. So here's where we built our roads. We have like Belgium, Fredonia 6. In fact, actually, let's so that's what our file looks like. Now, if we wanted to work exactly with what we have now, we probably want to go and take these spaces out. But what I'll actually go ahead and do, just go down into our parse road and say if road string at bucket I is equivalent to a space, just continue. So if you see a space, just skip it. Keep cooking with life. So by doing that, we now support this. You know, when it bumps into that space, it'll say, ah, just forget about that guy. Go on to the next spin through the loop. Okay, so now we have all of our individual roads being read in. Cities were all caps, right? Very handy. Or roads all lowercase, even more handy. So let's just switch these to all lowercase. Path of least resistance. Because ultimately, when you have a road between two towns, the towns only exist one time, but we might have multiple roads that go out of the same town. Okay, so We want to read this in. So when we read in Belgium Fredonia 6, the idea is that we have already had a town built called Belgium and a town built called Fredonia. That is towns with the identical name as those guys. Okay. So if I have a town collection, like I do in here. So my town collection has a collection of towns. It has a count and we build it with that guy. And then maybe I put a function in here, town pointer, get town. And this guy takes in a string town name as a parameter. His job will be to go through all of these towns for int I is equal to 0. I is less than count, I plus plus. Remember, we stored count in here because arrays in C++ don't know how many elements they have themselves. So that's why we created our special town collection, which holds 2 pieces of information, my collection of towns and how many of them there are. So if I want to ask that guy to please give me the town that has this name, I can pass him a name. We can go through all those towns for each town. And what's a town? A town has a, well, I want to be able to get the town name from this guy. So right now that guy is private. So I'll have to give myself a public getter for my town name. So I'll go and implement that inside of town CPP. So return town name. So now an instance of town knows how to spit out the name for it. And then let me quickly. I don't know if the double equal sign is supported or compared to. Yeah, compared to, or just compare. I think the double equal sign probably would work here since we're dealing with string literals. But this is the same thing as we would deal with in Java, where if I had 2 completely separate strings and I said, is this string equal to this string? So in Java, if I had something that looked like string S is equal to hello, string S2 is equal to hello, S equal S2 would be true. But it's not true because this string contains HELLO and this string contains HELLO. It's not comparing the contents of those 2 strings. What it's doing is it's saying, is the memory address associated with this the same as the memory address associated with this? The double equal sign is the primitive equivalence operator. So since these guys are both string literals, Java said, you know what? It makes sense for me to not create 2 separate places in memory to hold the identical string literal. I'll store that string literal once, and I'll give everybody who wants to be equal to it the same pointer, which is why this is true. But if I say string S3 is equal to a new string, hello, like that, and I say S equal S3, this is false. Proving the case that, yes, they contain the same string, but they are not in the same places in memory. Why? because I specifically asked for a new memory location for S3. But what I can do in Java is I can say S dot equals S3, and that'll give me a true. And I can also say S dot compared to S3 equals 0, and that will also give me a true. Compared to return something but less than 0 if S should come before S3, we'll say alphabetically, it's actually something called lexicographically. It'll return something greater than 0 if S should come after S3 alphabetically, and it'll return 0 if they're the same. All right, so this isn't some weird C++ function we're about to use. It's something that existed in Java. All right, bottom line is we can't rely on comparing a string to another string with a double equal sign unless that double equal sign in that language had been redefined to work on strings, like in Python. Python's done that. All right, so for us here, when I'm writing get town, I'll loop through all my towns. Each time through, I'll say if this, the towns at bucket I dot compare dot get what I call it, get town name. So that'll get the town name from that town the guy just wrote. Dot compare to the town name that was passed in. If that's equal to 0, then return the towns at bucket I. Else go on to the next town. Go through my whole collection of towns. Each time through, is the current town I'm looking at's name equal to the name I'm looking for? If it is, return that town. I check all of them. I didn't find it. It'll look like that. We can test this guy down here, reading in our town collection. I won't delete these anymore since we're going to actively use this. And I'll go ahead and say town pointer T is equal to TC, what do they call it, find town, get town. Change them to all lowercase. I'll do a C out on T. We should get a real memory address. Get town. Returns a string, get town name. String, return this town's name. That should be okay. Well, I'll go through and patch this up real quick. So for Wednesday, given these two pieces, and I'll give you a link to the current state of the code that's functioning. Given these two pieces, write the code that reads in all of our roads and actually creates the instances of roads from our towns. That is, it effectively does this part. Does that make sense? So in the end, we'll have two files, a file with all the towns, a file with all the roads, and then these two loops will go through and read in from those files, generating the towns and then generating the roads that connect those same towns. Because we're going to use our town collection to go and find me a pointer to an actual town that I need. Don't create the same town 5 times if there's 5 roads that go out of it. All right, make some sense. All right, I'll see everybody on Wednesday. Not call it get town name. Get town name there. Oh. Yep, it's an arrow, not a dot. I think that should work. There we go. It was an arrow, not a dot. Still recorded, so we're good. I'll make sure I get the assignment up.